Hi, my name is Moritz Kriegleder, and today I will give a talk about Enactivism, Life and Intelligence from a cognitive science perspective for the Angewandte Festival 2020. So I'm a student of physics and cognitive science at the University of Vienna, and in autumn I will start my PhD with Professor Knutila at the University of Vienna with the project Possible Life. And I'm mostly interested in mathematical models of the mind and the interaction with self-organization in biology and living organisms. And today I will talk a little bit about enactivism, a new view in cognitive science that switches around what we know about cognition. And I will also talk about how it will change our interactions with neuroscience and how it can inspire a new artificial intelligence. So, my talk is basically as an overview. The first part is to talk about what cognitive science is, what is the backbone of it, why do we need it, and the second part will be about the mind as a computer metaphor. This is interesting because a lot of novel ideas have been developed with the idea of the mind as a computer that has the brain as the hardware and the neural programs as software. Then I will go a little bit into enactivism and tell you why we start to see problems with this metaphor and how enactivism can help to develop new pictures of cognition. Then I would like to talk a little bit about the relations of life and mind in enactivism, because they are very interlinked, and some self-organizing principles from biology could be used to spark new ideas in artificial intelligence. And in the end, I will talk a little bit about what are the limits of the approach that we have right now, of the mind as a computer, when we develop new artificial intelligence, and how enactivism can help to overcome these limitations. So the cognitive sciences are usually understood as an interdisciplinary research field between 6 background disciplines. So obviously psychology is dealing with mental processes in general, and cognitive psychology as a subfield especially is the backbone of cognitive science, but also philosophy with long-ranging discussions about the philosophy of mind, very important to discuss discourse and interdisciplinary relations. Then we have linguistics as a big backbone of understanding how language developed in cognitive systems and how using different languages can also change the way we act or behave. Then anthropology deals with the evolutionary background of cognition, and neuroscience allows us to non-invasively image brain activity. So we can look at how neuronal activity changes when people do specific tasks. And last but not least, artificial intelligence is a strong influence because it allows us to model theories of cognition in a computer. This approach in cognitive science ideally should go both ways, so that computational techniques are inspired by biological function, but also our understanding of this biological function can be tested or extended via artificial intelligence. And cognitive science is usually traced back to the 1950s, where the behaviorist view in psychology was dominant. So the behaviorist view, very much in a nutshell, contained the idea that psychology only studies behavior. So we look at input-output relationships of stimuli and how these stimuli trigger behavior in humans, or also in animals. Pavlov's dog is a famous example of behaviorism. And in the 1950s, a lot of people from computer science, neuroscience, and psychology started to criticize the view that doesn't deal with mental processes. So behaviorists are usually not caring about what is happening in the brain during the input of stimulus and the output of response. But cognitivism tried to emphasize how important it is to understand what the cognitive system does in between these two steps. So cognitivism first started as an understanding of the mind as a computer. So researchers in the field tried to look for a set of equations that describe mental processes, the dynamics of mental processes. And this was very helpful in building the first computer archetypes that are inspired by biological computation. So computation where it just comes from the one who computes, which obviously at the beginning were humans, and try to understand how this computation takes place in the brain. This was later extended with artificial neural networks, the idea that our brain works through connections of neurons, and that we can model these connections in a computer by defining a network of computational units, and that do not look anymore for a set of equations how our mind works, but more in artificial intelligence the approach was to try to simulate these connections of neurons. And these artificial neural networks could learn through input and change the weight of the connections to solve a specific task. Enactivism wants to overcome this paradigm as mental processes as a computation of the brain. And I will, in the next section, talk about how. So the computer metaphor of the mind is very interesting in the way that it understands the brain as the hardware of the computer and the mental process as the software. So for a long time, we looked for an algorithm that our brain uses that could describe our everyday experiences, consciousness, and everything in between. This sees the brain as a passive information processor. So we get sensory information through our eyes, our nose, our ears, sense of touch, and the brain computes them and outputs behavior. So this is a linear process where you first have an external influence, a stimulus from the outside, then some computation, and then an output in the sense of behavior. Consciousness at the beginning was seen as a function of this information processing. So consciousness itself, in this view, is not something special, but it just arises because the brain computes information. The hope was that if we understand all neuronal activity that is going on in our brain, we'll also fully understand how our experience arises. Why do we perceive certain colors the way we do? Why do we choose certain actions? Why do we make decisions in a certain way? And this perspective is still dominant in psychology and neuroscience, but we start to see new approaches that tackle these ideas. So enactivism is, in the cognitive sciences, one of the big currents at the moment that challenge this view of the mind as a computer. And originally, it builds on work from Francisco Varela, a biologist, Eleanor Roche, a cognitive psychologist, and Evan Thompson, a philosopher of mind. It goes back to the book in 1991, The Embodied Mind. And the embodied mind basically is the idea that tries to take cognition or mental processes, not limited to brain activity. So what embodied mind really put forth is that mental processes only arise through the interaction of brain and body. So it's not a passive computation of the brain that gives rise to experience, but it's the interaction of the brain and the body. So how stimulus changes our behavior, how our behavior is changed by the way we can act with our body, and in general, something that we actively create by perceiving things in a certain way. If I look in a certain direction, I will get different sensory information than if I don't look in that direction. And also the way our senses work dynamically influence our mind. And then the radical extension of this idea was the inactive mind. So if we move beyond the border of our bodies and see cognition or consciousness as a co-creation between the mind and the world. So we cannot separately look at how our mental states are processed inside of our body, but we also have to look at how the environments of the cognitive agent look like. Because how my environment looks like would always change how I process information, how I understand information, and how I contextualize it. So a nice book from Evan Thompson's amazing book, Mind and Life, describes this idea in the following way. The nervous system is an autonomous dynamic system. It actively generates and maintains its own coherent and meaningful patterns of activity. The nervous system does not process information in a computationalist sense, but it creates meaning. So the meaning part in enactivism is usually, meaning is always constructed between an environment and an agent. So it's not the individuum itself that creates meaning for itself, but only in relation to its environment. Okay, so the relation from life and enactivism is very close. The idea of enactivism developed all out of the autopoiesis framework from neurobiologists Humberto Maturana and Francisco Varela, who published a very interesting paper about the organization, the self-organization of biological systems. So the idea here was not that we look at life as a set of properties that a system has, like a checklist, and if you fulfill all the checklists, you're alive. But the idea was, what makes life special? And their conclusion was, it's a self-organization. So autopoiesis describes the organism's capability to produce itself. Producing itself is meant that it closes itself off from the environment, like with a membrane of a cell, for example, and it produces itself, meaning it maintains its own dynamic. So the cell has a kind of dynamic that has to be maintained, even though the environment puts a lot of thermal pressures or radiation or other things. So the living of the organism is a process that happens when there is some kind of unity. Revolutionary thinker Lynn Margulis described this process view of life as life on Earth is more like a verb. It repairs, maintains, recreates, and outdoes itself. So we look at how we organize ourselves as making sense of life in general. Another important part, obviously, because time doesn't permit a very long explanation, Evan Thompson has an important relation of life and cognition. They are basically depending on each other, and you cannot think the one without the other. So enactivism assumes that autopoiesis is a necessary condition for life and cognition, but it's not sufficient. So we also have to have complex interactions with the environment, and a thing is called metacognition. So the possibility of an organism to observe itself and to make judgments about its own state. In a nutshell, the connection of life and mind and autopoiesis can be described by the 5 steps of cognition from Evan Thompson. So he assumes that the first one is life arises through autonomy. So if we have a closed unit that produces itself, plus adaptivity. So the possibility of adapting its own structure and dynamics to fit the environment. Then this autonomy entails the emergence of an identity. So if something has a closed structure and has some kind of dynamic and develops autonomy, this leads to the perceiving of identity. The closed biological unit could be seen as the smallest example of personal identity. The third step is the emergence of an adaptive identity that leads to the emergence of a world. So if I, as a personal unit, can adapt to the environment, then I also have to make sense of the environment in some way. And making sense of the environment leads that I perceive the environment as my world. So in phenomenology, this is called the life world, the way the external states appear to the closed-off system. This could change. Everybody has a different life world, and Enactivism doesn't make assumptions about how these life worlds have to represent a common world, but it assumes that we create this world together. This leads to the fourth step, emergence of adaptive identity, and the world is the process of sense-making. So if we have an adaptive identity and perceive the world in a certain way, then we make sense of this world. And we see ourselves embedded in this bigger world. And this is what they call the process of sense-making, which is crucial for understanding Enactivism, because even Thompson relates sense-making directly to cognition. So what cognitive systems do is they make sense of the world that they are embedded in. As a picture, I have here the Ouroboros, the mythical snake that bites its own tail. So because we make sense of the world, and the world already shapes how our dynamics and our structure look like, we cannot say what comes first. There is a co-creation going on between the world being a certain way and the organism self-organizing in a certain way. So there is no background world that we perceive and then react on it, but there's also no radical construction of the organism of the world. It's a co-evolution of both. Okay, so coming now from life and cognition to artificial and biological intelligence. So how can we develop a true artificial intelligence? Well, since we're constantly discovering new breathtaking abilities of living systems, the border between artificial intelligence and biological intelligence is constantly shifting. So currently, all of our big artificial intelligence algorithms, such as machine learning applications and artificial neural networks, learn passively from big sets of data. So we collect data, structure it in a certain sense, and then feed it into the algorithm, and the algorithm changes its internal structure to optimize a certain function. Obviously, this function and the goal to which it's optimized to is given by the programmer. So there is no active inference happening in the program. The hope of machine learning is usually that with bigger and more precise sets of data, we can create perfect algorithms that will lead to an artificial intelligence that can solve every task. This leads to the big difference between expert intelligence and general intelligence. Machine learning and artificial intelligence approaches has led to many great developments. For example, think of the chess computer Deep Blue, which outplays every chess champion and is way faster and more precise at finding the best way to win a game. This is a perfect example of expert intelligence because it optimizes its inputs and its behavior so that it can predict how to, in the fastest way possible, win the chess match. There's nothing else going on. The artificial intelligence is only programmed to do this one thing, and it doesn't understand the context of chess in general. So you can think of an expert intelligence as like winning the game, and the general artificial intelligence is understanding the context of the game. For example, that you have like a board with chess pieces and you play against humans, and the goal of the general intelligence is to make sense of an unknown environment. Because this is something that we think that humans do still much better, making sense of completely new tasks that have not been there before. If you take the software of an autonomous driving car and let it solve crossword puzzles, it won't succeed. But if you take someone who always did crossword puzzles, they could have the ability to learn driving. So we humans are very good at things that seem very trivial, but actually they are not to artificial intelligence. For example, going to a friend's house and making a cup of coffee. This is one task that robotics continuously fails to do, because you have to have a lot of context going on between making sense of your environment, knowing different possibilities, how to move around the house, and how to make coffee. But this is something that we do every day, and it's not uncommon for us to think that this is trivial, but actually it's much more complicated. So my point is here to develop a general intelligence that can make sense of new tasks. It will not help us to have bigger sets of data, and also not more precise data. We need to have a new approach that resembles more like we humans solve tasks that we never did before. And the enactive approach here makes very clear statements of how to understand this. So, as a picture, I showed you a nice algorithm called self-organizing maps that gets an input of data points, and the self-organizing map has the goal to structure these data points in a way that the more similar the data points are, the closer they are together. And on the top you see the data points that are completely spread over the whole space, and on the bottom you see something that looks like it made sense of the data, but it was just passively computing what was going on according to a pre-programmed function. So the enactive approach would entail that we have some kind of active inference. So the idea of building models of the world. One nice approach here is called generative artificial intelligence. Generative AI tries to not only passively get the information, but also lets the algorithm create its own models about what this information represents. The idea is here that we don't only get like spread out data sets, but the artificial intelligence tries to find causes that would lead to such data. So it not only receives it, but it also makes predictions about what could be the source behind the data looking a certain way. These generative models are already used in neuroimaging, so brain scans, to make sense of which areas in the brain cause which activity in other areas. And most recently, one of the inventors, Carl Friston, used this generative AI approach to model the pandemic. According to him, in a Garden interview, it was very successful, but we're still at the beginning stages, so will others decide if it's helpful or not. Okay, so how can we make sense of consciousness in the age of big data? My argument here is that just having powerful computers and huge amount of data will not make sense of experience in any way. My idea, coming from Enactivism, is that we need a more active approach also for artificial agents. We not only need to look at how information is processed, like it is in the brain, but we also need to look at interactions with the environment. And for this, we need an enactive approach. Enactivism would understand consciousness more as a dynamic process than a software. This dynamic process happens between organisms and their environment in coevolution. So the interactions are more important than specifying what the brain does and then looking how it behaves in an environment. But we have to look at the creation of both of it. We have to look at the environment and neuronal activity to understand how these influence each other. I would like to close off with a nice quote from Francisco Varela, who also takes this approach to philosophical and also political argument. So he says, if everybody would agree that their current reality is a reality, and that what we essentially share is our capacity for constructing a reality, then perhaps we could all agree on a meta-agreement for computing a reality that would mean survival and dignity for everyone on the planet. So, to give you a short conclusion of the points I made here. So, the mind as a computer analogy has taught us a lot about neuronal dynamics and inspired interesting developments in AI. But to understand consciousness, we have to take an enactive approach that looks at how we co-create the world around us. How does the environment change? How do we change? And how is this interaction going on? We cannot think these both things separately. Instead of a neuronal algorithm, consciousness appears to be more a dynamic process between living organisms, self-organizing biological systems, and their environments. And this again is a co-creation of both things. I argued also how this could actually not challenge artificial intelligence as a field, but even let it extend to new heights maybe with active artificial intelligence. This can lead to the development of novel artificial intelligence, but also can radically change our understanding of our own minds, how experience arises, and how we as subjects perceive the world around us. And with this, because the Angewandte Festival is taking place at the perfect time, I would like to remind you of something that is dear to my heart. As a climate activist, I was involved in the Klimavolksbegehren, which is an Austrian petition to have climate goals, put that into political power as well. So if you're an Austrian citizen or no Austrian citizens, I would really recommend to go to klimavolksbegehren.at and check it out and sign it. It's only possible this week. So at the end, these are my references. I can, as a starting point into Enactivism, really recommend the book of Maturana and Varela, The Tree of Knowledge. Very easy, short read to get an introduction. For the more in-depth, I highly recommend The Embodied Mind. It's a very important book in cognitive science, and even Thompson later followed it up with his book Mind in Life, which really puts forward how cognitive science can go from here. What are the new developments? And then, if you're more interested in the application to artificial intelligence, I highly recommend the paper by Fröse and Ziemtke, Enactive Artificial Intelligence, that should inspire more direct developments in technology. And since we cannot have a discussion, which is very sad because I would be very happy about that, I put my email at the end. So if you have any questions, recommendations, or just want to discuss these topics, I would be happy to receive an email and have a discussion with you. With that, I would like to say thank you for inviting me for a talk at this festival, and I hope it's going to be nice, and see you soon.
Eins 711 333 333. Die APL Performance Hotline. Please hold the line. Sie werden in Kürze verbunden. Für die dringende Unterstützung für Performerinnen und Performer vor oder nach einer Aufführung drücken Sie bitte 2.
(01 711 333 333). Die APL Performance Hotline.
Welcome. The APL hotline is here to help you. 01 711 333 333.
Das ist die APL Hotline. Please hold the line. Sie werden in Kürze verbunden. Die APL Performance Hotline ist während der Festivalwoche 22. bis 26. Juni von 0 bis 24 Uhr erreichbar.
1 711 333 333. Die APL Performance Hotline. Please hold the line. Sie werden in Kürze verbunden. Für die dringende Unterstützung für Performerinnen und Performer vor oder nach einer Aufführung drücken Sie bitte 2.